In this video, we'll practice finding limits of piecewise defined functions. Here's the first problem. Find limit x approaches 0 fx and limit x approaches 1 fx where fx is defined like this. It's 2x plus 3 when x is less than or equal to 0. Here it's 3 times x plus 1 when x is greater than 0. Pause the video, try this out. Okay, so we have to find limit at 0 and at 1. 1 is easier because it's cleanly defined. When x is approaching 1, we can use this definition. This works for all values that are greater than 1. So we can simply plug the value of x as 1. So let's do that. Limit x approaches 1 fx is defined as limit x approaches 1 3 times x plus 1. Because fx is equal to 3 times x plus 1 for all values that are greater than 0. So anything to the left or to the right of 1 will be using this definition. So let's plug in 1 because this is a polynomial. We can directly plug values. This is 3 times 1 plus 1. That's 3 times 2. That's 6. So limit x approaches 1 fx, that's equal to 6. What about limit x approaching 0? Now for 0, we have to be careful. We have to look at both these definitions. For the left hand limit, we'll have this definition, and for the right hand limit, we'll have this one. Let's solve them one by one. Limit x approaches 0 plus, which means the right hand limit of fx, that's going to be 3 times x plus 1. That's limit x approaches 0 plus 3 times x plus 1. Now plugging in 0, we get 3 times 0 plus 1. This gives us 3. What about the left hand limit? Limit x approaches 0 minus fx. Now for this, we'll use this definition, 2x plus 3. This is going to be limit x approaches 0 minus 2x plus 3. Now, because this is a polynomial, let's plug in 0. We have 2 times 0 plus 3. That's again 3. So left hand limit is equal to right hand limit is equal to 3. This is how we define limits. When both the limits are same, we can say that the limit exists. So the limit exists at 0 and it's equal to 3. So we can say that limit x approaches 0 fx, that's equal to 3. Let's solve one more. Suppose fx is defined as this. A plus bx for all x less than 1, 4 when x is equal to 1, and b minus ax when x is greater than 1. If limit x approaches 1 fx is equal to f of 1, that's given in the question, what are the possible values of a and b? So this is the definition. This is the clue. What are the possible values of a and b? Pause the video, try this out. Okay, let's do this together. If the limit at 1 exists, this means that the left hand limit is equal to the right hand limit. And we're also given that the value of this limit is equal to f of 1, the output when we input 1. And what's that? When x is 1, the output is 4. So not only do we know that the left hand limit and the right hand limit are same, we also know that both of them are equal to 4. Let's use them to get equations in a and b, and then we'll solve those equations for the values of a and b. So let's do that. Limit x approaches 1, that's equal to f of 1, that's equal to 4. This is given, which means that the left hand limit, limit x approaches 1 minus, that's going to be equal to 4. That's also going to be equal to limit x approaches 1 plus, which is the right hand limit. Both of them will be equal to 4. So let's take these limits one by one. X approaches 1 minus, we'll use this definition, a plus bx. So this is equal to limit x approaches 1 minus a plus bx. Now let's plug in 1. This is a plus b times 1, that's b. So this is a plus b. This is equal to 4. That's equation 1. Now let's find the right hand limit. Limit x approaches 1 plus fx. For this, we'll use this definition, b minus ax. This is limit x approaches 1 plus b minus ax. Now plugging in 1, we get b minus a. This is also equal to 4. Now we have these two equations and two variables. Let's solve for a and b. If we add them, this is 2b equals to 4 plus 4, that's 8. So 2b is equal to 8. This gives us b is equal to 4. And if b is 4, 4 minus 4, that's 0. So a is equal to 0. Let's solve one last problem. If fx is defined as this, mx square plus n when x is less than 0, nx plus m when x is between 0 and 1, and nx cube plus m when x is greater than 1. Now for what integers m and n does both limit x approaches 0 fx and limit x approaches 1 fx, both of these limits exist? Pause the video, try this out. Alright, now the same principle will work here. If the limit exists, this means that the left hand limit and the right hand limit, they're both equal. So if the limit at 0 exists, we can say that the left hand limit at 0 is equal to the right hand limit at 0. And if the limit at 1 exists, we can say that the left hand limit at 1 is equal to the right hand limit at 1. We have these two variables m and n, and we'll get two equations, one from here and one from here, and we'll be able to solve for m and n. Let's do that. For this one, left hand limit at 0, we'll use this definition, mx square plus n. So this is limit x approaches 0 minus mx square plus n. This is the x approaches 0 plus, which means the right hand limit at 0. So we'll use this definition, nx plus m, limit x approaches 0 plus nx plus m. Now plugging in 0 on both sides, we get n here and m here. So mx square gets cancelled, nx gets cancelled because x is approaching 0. So we have n is equal to m. This is interesting. If we have to make sure that the limit at 0 exists, we have to have these two variables the same. N should be equal to m. What about this one? Left hand limit at 1, we'll use this definition, nx plus m. X approaches 1 minus nx plus m. And for the right hand limit, we'll use this definition, nx cube plus m. This is limit x approaches 1 plus nx cube plus m. Plugging in 1, we get n plus m equals to nx cube. That's also n plus m. So this is even more interesting. What this result is saying is that n plus m is always same as n plus m, which means you can pick any integer you want. Limit at 1 will exist no matter what the values of n and m are. So in this case, we pick the same integers, n should be equal to m. And in this case, we can pick any two integers, their sum will always be equal to their sum. So this equation will always hold true. And if we want both the limits to hold true together, this means we'll take their intersection. We'll not pick any two integers, we'll pick the same integers. By doing this, we'll make sure that the limit at 0 exists as well as the limit at 1 exists. So the answer to this is both work when we pick the same integers. So for what values of m and n does both the limit exist? All values where both of them are the same integer.